My name's HiepIT, and today we'll continue with the series to go Google Onsite. So Google Onsite interview problem on Leetcode with the mock assessment feature for premium users. Okay, let's get started. If you random problem set. Okay, so we have 4 questions here. We can ship a string by ship each of its letter to its successive letter. For example, ABC can be shipped to BCD. We can keep shipping the string to form a sequence. For example, that we can shifting ABC to form like ABC, BCD, something. A given array of string, group or string that belong to the same ship sequence. You may return the answer in any letter order. So ABC. So look like for ABC, right? So it's have the like the distance of one like 1 and for BCD the distance, this one C minus B or D minus C will be 1 yes. So the first idea that's we iterate them and calculate the distance. So if it's the same distance, then it should be the same. So but this is the array. You can make it a tuple if you want. You can make it a tuple. For example, that okay, I will have an answer here. Maybe not an answer, but group them together, right? Group them together. The groups here. So default objects for strings. I will have a function to get the key from the string. I may calculate the distance of it. So I have a key here. Array. Look from what happens if you have only one character. Maybe empty. A tuple empty is a tuple empty, correct? So I grant from this one to length of string. So the key here will append with the s of I minus of os, s of I minus with os, I minus 1. This is the key of array. I need to make it like a tuple so it can be hashable. So groups of get key from string s. I append with the s. In case of empty, can it make a tuple? In case of only one character, right? So it's this empty. Not sure, but let's get the answer from it. Return groups dot value. Yes, correct. Ooh, what the hell? AZ correct. BA. Ooh, it can be rotate. It can be rotate, right? It can be rotate. So it means that BA. No. AZ. And this can be rotate into the +1 and B and A. Okay. So it can be rotate. For rotate, I can, if it's negative, right? It's negative, so I can plus with this one and modulo with this one. Yes, plus this one modulo this one, then it's good. So it can be rotate. Yes. Okay, so the time complexity of this, time complexity of this will be this one and this one. So should be the, maybe the n multiplied by l. Okay, where n in number of string, l the length of each string, whereas length of each string. Yes. Yes. By maybe all of the string. All of the strings. Which one? Okay. Good. Easy. Let's move to the question 2. Given n multiplied by n to the binary grid represent a map of 1 and 0, 1 land and water and 0 water. Return number of islands. An island is surrounded by water and is formed by connecting adjacent land horizontal or vertically. You may assume for it are surrounded by water. This is the basic problem to calculate the number of islands. Let's do it very quick. It's very basic problem. Just DFS or BFS. Breadth first or depth first in mind. I have a visitic array force multiplied by n for in range of m. Okay, this is the answer here. DPS row column for direction, new row, new column. If it's invalid, or it's water. Continue. Otherwise, we visit it. I modify it. Mark it like visited. Mark as visited. Modify it. In case if you don't need to modify, if you don't want to modify it, you need a array here. But I modify it. I don't need a visited. Okay, and then I just go to the neighbor. Okay, go to the neighbor. So oh good, I return 1 for range, number of rows, number of column. If row column equal to 1, then this one plus what go to it. It's an answer. Yes. New row, new column. It's good. Yes, it's good. I need to define a deer like a single graph. Yes. Let's make it nice. 1 should be correct. Yes. Yes, okay. Time complexity of this should be e plus y v, number of edge and number of vertex, and number of edge here is 4v, right? Because for one vertex, one cell, it will go to the 4 neighbor. Yes, this one like so the total will be 5v. V here is n multiplied by m. So I remove the constant, so it's this one, where in number of rows and in number of the number of rows, and this one is the number of columns in the grid. And space will be the depth of the S here. So in case something is goes like this, so it will be n multiplied by n. Yes, easy. Move to the question 3. Given rows multiplied by columns string and a sentence represent a list of string, return a number of times the given sentence can be fitted on the screen. The order of words in the sentence must remain unchanged, and a word cannot be split into 2 lines. A single space must separate 2 consecutive words in array. Yes, for example, that I have a number of rows and number of column here, so 2 rows here and 8 column, 8 character. So I need to fill the words and keep its order. For example, I need to fill the hello first, so the hello will 5 character, you consume 5 character, and I need a space for it. And for the remaining one, I still have only 2 remain character, but I need to fill the next word like word 5 character, so I need to go to the next line, so like this. So in this I can only fill one sentence, hello world, and that's all. For this one, like 3 column, 3 rows, and each row have 6 characters, up to 6 characters. So I need to fill it one by one, like A space, BCD space, and E space, and I repeat the whole sentence, try to repeat the whole sentence. A and BCD, but don't have enough for BCD, I need to go to the next line, BCD, E space, and E, and that's all. So have a 2 sentence completely filled. For this one, let's do proof box solution. For the proof box solution, like I need to number of rows here, go to in range of rows here. I try to fill one by one word index, your row. I have the answer your row here, so I start with this line. For this, like I will wide the words, sentence of word index enough for the rows here, enough for it. Then I just plus 1, but I need to calculate the next one will be length of this one and plus what the space, one space. Length of this one plus what the space, yes. This one, so if this one is equal to length of the sentence, then answer will be +1. Return answer is correct. Okay, for this row I try to fill it. For this row I try to fill it. For this row I try to fill it by if it's can fill the next word, then I fill it and calculate for the next one. For example, I have fill hello, and for the next one we'll start from this one plus what the space here. So if it full for the sentence, I plus the answer 1. Yes, correct. Why our brain why is our brain why our brain why it our brain what the hell word index is start with 0. I need to reset is why I forgot it. Yes. Okay, so this is the proof of solution. So this is the proof of solution. So this is proof of solution. Solution 1, proof of solution fun proof of. So the time complexity will be the number of rows here, multiplied by, for this one in the worst case it will be columns. Right? When this one is like 1 character or something, each time it's move only 2, and so it's row multiplied by column, and this base will be 1. So this is the time complexity of the proof of solution. But this one, so it will be DOE since number of rows here like very big, and columns here is also very big. Yes. Can we have a solution to can we optimize this part? When we start with the next line, start with a new line, how can we calculate the word index, the next word index, faster compared to we look like this? Can we calculate it fast from the new line to the new line? We calculate the number of times, the number of answer here, and the next word index. I think I can use a dynamic programming for it. This start the new line. This start from the new line, but I need to input the current word index. So this one should return for me the number of complete sentence, number of complex sentence, and the next word index. For this one, right, I optimize this one, next word index. Yes. Where when we start a new row and the current and field from the current word, is this one. Yes. Okay, so let's move to this one. This one, maybe the number of complex sentence. Count complex sentence 0, and next word index here. Okay. This should be start with 0. Okay. And this one, so this one will plus 1. Return this one. Return is a tuple, and the next index. Yes. And I cache it. So this one, I don't need this one anymore. So this one will be from the worst index here. I have the worst index and completed. Count completed. Okay, answer will plus what? Count completed. Yes. Return number of completed sentence and the next word index. When we start new row view from the current word. Okay. Okay, just view it. Yes. 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 Yes, we can pass now. So what the time complexity here? Time complexity here will be this will independently. So this one will take rows here, and this one independently. This one will, when it had a result, it will cache it. So the word index here, how many index it have? It's have like the number of sentence length of the sentence state. This is a number of state. For each state, it will do the linear here. So it will be multiplied by clumps. Okay, so where rows this one clump and it length of the sentence. And the space will be the number of states here will be end. Yes. This one up to 2 million, then it should pass. Yes. Who? Go to the next one. You are given an empty 2D binary grid. Size m multiplied by n. The grid represents a map where 0 represent water, 1 represent land. Initially, all the cells of the grid are water cell. So all 0, okay. We may perform an add land operation, which turns the water at position into a land. You are given an array positions where position, this one is a position, or this one, at which we can operate add operation, return array of integer answer, where answer add is the number of island after we turn this one into the island. Okay. Let's consider this example. Consider this example. Okay. So we have the n rows here and n column, right? N rows and n column. Okay. So 3 multiplied by 3 and initialize with water here, water 0 here. So the first operation, I will turn 0 into the land. Okay. So the number of island will be 1. The second one, I will turn 0 1, this one, into the land, and then the number of island will be 1. The third operation, I will turn 1 2 into land, so the number of island will be 2. For this one, I turn 2 1 into land, so the number of island will be 3. Okay. For this one, if we do the proof of solution, for we iterate from its position here and we make it as a land, and we do DFS to calculate the number of islands. So it should take the time complexity, then like the number of position here. So P multiplied by DFS for the whole matrix. So it will be M multiplied by N. So this one is 10 exponent by 4 and multiply by number of position here, position length here. So this one, so it should be the solution 1 proof box. So if you take the time complexity of this one, P multiplied by M multiplied by N, where P less or equal to this one, very big, M multiplied by N less or equal than this one, very big. So it will be time limit exceeded. Time limit exceeded. By complexity will be, by complexity that will be N multiplied by N plus put the answer. Okay, so this is a proof of solution. So it will be time limit exceeded. So we need to find a better solution. Let's think a bit. For this one, 1. For this one, okay, this one, 1 land, 1. This one, like this one already land, and this one is a new land, and we check if it's connected or not. If it's connected, then we minus 1. So it means that how we check it's connected. We link 4 direction. Okay, so this one is have 2 land here. If we can link it into this one, so it's become 1 land. Okay, do the same. This is 1 land. Okay, and this one a new land. So we have 2 land. 2 land. So if we connect, so it become 1, but it cannot connect, so it will keep 2. Okay, so this one, like, we have 2 here and we have a 1 here, so we have 3 land. If it's connect, then we minus, but if it doesn't connect, then it's 3. What happens if we have 1 here? What happens if we have 1 here, right? So it will connect. So if it can connect, so it should be 2, and this can connect this one. So okay, when we have a new land here, so it should be 4, right? This can connect this one, so it's not 4 anymore. Can connect this one. When this can connect this one, so it will be 3. But it can connect this one. So this one is not a isolated component anymore. This is already connect, so it will become 2. And this one can connect to this, so it's become 1. So we can use the union find here to connect them together. Yes, let's implement it. Solution 2, union find. Okay. I have a union find. Look from row column in position. Maybe connected component. Maybe component or connected component. 0. If I turn it into the land, so if grid, I need to have a grid initialize with 0. Initialize 0. Okay, if it's a I mean it is already a land, then we do nothing. So if it's already a land, we do nothing. This is not processed yet, and +1, and we need to look for direction, new row, new column. If is out of bound, or it's either water 1, then continue. Otherwise I will union. So if I can union between row column to the new row, new column, if I can union it, then this one will -1, and I need to have an answer here. answer here array. Fine. In this case, it will be this one. Otherwise, it's a bandwidth this one. Yes, return the answer here. Okay, all I need to do is that I need to implement for the unified. So the time complexity, what this should be the length of per session, and this one unified. If I implement using both combination of path conversion with union by side or union by rank, so this should be O1. This should be O1 here. So plus what multiply is 1. So this is the time complexity of this solution. By complexity will be the same. Yes. Yes. Okay, all I need to do is I need to implement for the unified. I can use the dictionary for it because I make it as a tuple. I can implement union by side as it mixing if not existing. Okay, the side we want. Okay, fine. If I do the path conversion, okay, this equal path conversion. Okay, I can do the union PU PV is already connected, then I return false. Okay, I check side. Merge from the smaller size to the larger size. Larger size equal to small plus with the small size, and parent, the small one we point to the parent of the small one, we point to the max one, and the size of it we plus with this one. Otherwise the opposite one. Okay, and two can connect them together. I need to add a mixing row column, new land into it plus 1. Okay, dear like a sync graph. Okay, incorrect. Let's check why it's incorrect. Unify parent side not set one different, do path conversion PU PV equal return false, sign less than this one, point to this one, opposite. Okay, this one correct. Union 5, grid 0, 0, 1, 0, 1, 0, 1, 0, minus 1, 0, okay. Answer. This one. If it's already max equivalent before, then no change. So this one, okay. Active mixing, okay. For direction. New road, okay. Is it okay? If I can union, okay. What was wrong? Why I have bug? Why I have bug? Why I have bug? Why I have bug? I need to make it one. Mark it. Yes. What? What? Yes. 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 Yeah. Thank you for watching. See you next time. Bye bye.